Have you ever heard of someone wrestling a satellite in outer space and winning? Sounds like science fiction, right? But it's not. This is the unbelievable real-life story of NASA astronaut Joseph P. Allen, the first and only human to have physically wrangled a satellite while floating freely in the vacuum of space. But that's not even the wildest part. Just moments before his daring maneuver, Joe became one of the few humans in history to float alone in space with nothing but a jetpack strapped to his back. No tether. No safety cable. Just him, the stars, and a system of tiny thrusters keeping him alive. Now that's what you call a rough day at the office. But how did it come to this? What led Joe Allen and his team to be involved in one of the boldest rescue missions in NASA's history? You see, back in the 1980s, NASA was experimenting with ideas that today would seem downright impossible. Technology like this doesn't even exist anymore. But during those early years of human spaceflight, NASA had a kind of fearless ambition. It felt like they could do anything. One of the most astonishing examples of this daring spirit was what became known as the Twin Satellite Rescue Mission. It was the kind of operation that seemed too crazy to work, until it did. It all began in February of 1984, during the 10th flight of NASA's Space Shuttle program. This mission also marked the very first test of a new piece of technology called the Manned Maneuvering Unit, or MMU. Imagine a personal spacecraft that straps onto an astronaut like a backpack. That's essentially what this was. A compact propulsion system that allowed astronauts to fly freely through space without needing to be connected to the shuttle. At the time, there was no International Space Station, nowhere in particular to visit. But the vision was clear. Astronauts could glide from one spacecraft to another, completely untethered, using only their hands to control two joysticks. Those joysticks operated 24 tiny thrusters that released brief bursts of nitrogen gas to control movement in all directions. One stick for rotation, the other for directional movement, forward, back, up, down. It was like driving a space motorcycle but with way more at stake. On that first test flight of the MMU, astronaut Bruce McCandless gave us one of the most iconic images in human history. A lone figure floating high above Earth, untethered, suspended in the black void. No lines. No lifelines. Just pure isolation. He was the first person in history to achieve this kind of freedom in space. That image captured the imagination of millions. It was a moment of inspiration, adventure, and raw courage. To go where no human had ever gone, to be more unbound than anyone ever had. But the photo also carried an undercurrent of dread. The sheer vulnerability of it, being so exposed, so isolated in the endless chaos of the universe, was haunting. And yet, Bruce and his fellow crew members weren't out there just for the photo op. They had a serious job to do. Their space shuttle had carried two large communication satellites, Palapa B2 and Wester 6, into orbit. There was nothing especially unique about these satellites. They were standard, valuable communication systems, the kind that millions of dollars were invested in to provide coverage across the planet. Launching satellites was common for shuttle missions. Nothing seemed out of the ordinary. But this mission was about to become anything but typical. What happened next would change how we think about satellite launches and orbital operations forever. Here's how it worked. When the shuttle deployed satellites like these, it used a device called a Payload Assist Module, or PM. Think of it as a small rocket engine attached to the satellite. Once the shuttle releases its payload, the PAM fires to push the satellite into its final orbit, typically a much higher altitude than where the shuttle can reach. In this case, both Palapa B2 and Wester 6 were meant to go into geostationary orbit, about 22,000 miles above Earth. That's far beyond the 600-mile altitude limit of the space shuttle. So the PAM was crucial. But disaster struck at the worst possible moment. As the PAM was igniting and pulling away from the shuttle, the astronauts noticed something strange. The smooth, continuous exhaust trail suddenly transformed into a giant puff of gas. That's a sign of trouble. It meant the engine had malfunctioned mid-burn. More specifically, the nozzle had broken off completely. Without it, the thrust wasn't strong enough to push the satellite into its proper orbit. And just like that, both satellites were floating aimlessly in the wrong part of space, essentially useless. This kind of catastrophic failure is rare. Most space missions go off without a hitch. But when something goes wrong, the consequences are massive. Satellites, especially in the 1980s, were incredibly expensive. This wasn't the age of tiny CubeSats orbiting by the thousands. Each of these machines represented an enormous financial investment. And smart companies protect their investments. That's where things get really interesting. Enter Lloyd's of London, a legendary global insurance market that had been around since 1688. Yes, you heard that right. A group that started insuring wooden ships and cargo over 300 years ago was now involved in satellite insurance. By 1984, Lloyd's was still holding on to its old-school charm. Men in suits, handwritten ledgers, wooden desks, but they had evolved with the times. And they weren't just covering ships anymore. They were insuring skyscrapers, movie stars, even space hardware. They had policies on both Palapa B2 and Wester 6. Now Lloyd's isn't your average insurance company. It's a marketplace of underwriters, wealthy individuals, sometimes backed by syndicates, who pool their money to cover high-risk, high-reward ventures. These people were used to gambling millions on shipping routes, architectural wonders, and yes, even satellites. They had once paid out £1 million to the owner of the Titanic. They had insured Mariah Carey's voice for $35 million. And now they were staring down a $180 million payout for 2 failed satellites, the largest insurance loss in space history at that time. But Lloyd's wasn't about to walk away quietly. After all, once the insurance money was paid out, the underwriters technically owned the satellites. And as it turned out, these weren't broken satellites. They were perfectly functional, just stuck in the wrong orbit. Getting them to their intended altitude was considered impossible. After all, their propulsion modules were useless, and there was no way to strap on a new PAM engine while they floated in space. But the idea of abandoning $180 million worth of tech didn't sit well with these aristocratic investors. They weren't interested in writing off the loss. Instead, they started to explore what might be the most unlikely question ever asked in the insurance world. What if we could bring them back? The satellites, though lost in orbit, were still very much functional. They could be resold to anyone in need of a communication satellite for a fraction of what it would cost to build a new one from scratch. This gave the underwriters a unique opportunity to recover some of their losses. If the satellites could be retrieved, refurbished, and sold again, it would offset a large chunk of the insurance payout. It wasn't a perfect solution, but in the insurance world, every dollar recovered matters. All they needed now was someone bold enough to go up there and bring those satellites back. Steven Merritt, an underwriter for Lloyd's, saw this as the perfect chance. He wasn't just some guy in a suit, he was smart, strategic, and had a deep understanding of how government agencies operated. Merritt knew NASA was eager to prove the capabilities of its brand-new Space Shuttle orbiter program. He also knew about the MMU, the Manned Maneuvering Unit, essentially a jetpack for astronauts, and the Canadarm, the robotic arm on board the shuttle. Both were specifically designed for handling, repairing, or retrieving satellites. Merritt approached NASA with an offer. Lloyd's would fund a mission and pay NASA $10 million to retrieve the 2 lost satellites and bring them back. From a business standpoint, it was a win-win. Lloyd's would still take a loss, sure, but a smaller one. They could then resell the satellites and save millions. From NASA's side, it was a chance to prove the shuttle could perform complex tasks in orbit beyond just deploying payloads. The agency accepted the proposal and soon preparations began. NASA selected mission specialists Dale Gardner and Joseph Allen, both experienced, highly capable astronauts, for the job. These two would undergo rigorous training on the MMU to simulate the high-stakes satellite recovery maneuver they'd be executing hundreds of miles above Earth. NASA engineers got to work as well, developing a new specialized tool for the mission. It was called the Apogee Capture Device, though astronauts affectionately referred to it as the Stinger. This tool would mount in front of the astronaut and be used to latch onto a satellite. The technique was clever. The astronaut would fly close, insert the Stinger into a satellite's maneuvering thruster nozzle, and then pull a lever. This expanded the tip of the Stinger, locking it firmly into the combustion chamber. With a secure hold, the astronaut could maneuver the satellite with the MMU, bringing it slowly back to the shuttle. Once close to the orbiter, another clamp would be attached to the satellite's bottom. This clamp allowed the Canadarm to grab hold of the satellite and move it precisely into the shuttle's payload bay. There, it would be locked down and safely secured for the return trip to Earth. This recovery would put one of the shuttle's most ambitious design promises to the test: the ability to not only send payloads into space but also retrieve and return them. On November 8, 1984, the Space Shuttle Discovery launched for what would be NASA's first-ever satellite rescue mission. But as always with space missions, nothing ever goes exactly to plan. The first target was Palapa B2, still orbiting 210 miles above Earth. Ground controllers had already fired its guidance thrusters to reduce its altitude and rotation speed, down to just about 1 revolution per minute. Astronauts Gardner and Allen got suited up and set up inside Discovery's open payload bay, ready for their attempt. Allen would pilot the MMU, while Gardner remained in the bay to assist. Inside the shuttle, astronaut Anna Fisher would operate the Canadarm, carefully watching as her crewmates began this delicate orbital dance. Joe Allen maneuvered out into space using the MMU, floating toward the satellite like something out of a science fiction movie. The sun was in his eyes, making it hard to see clearly, but he managed to guide the Stinger into the thruster nozzle. With a flick of the lever, the grappling hooks engaged. He was now literally riding the satellite. Using the MMU's thrusters, he stabilized Palapa's rotation, gently bringing the satellite under control. Everything looked perfect, until Gardner tried to attach the clamp. To everyone's shock, it didn't fit. Somewhere in the planning process, someone had miscalculated the satellite's dimensions. The satellite's antenna, when retracted, made the bottom section slightly different than expected, and the clamp just couldn't lock on. That meant the Canadarm couldn't be used to help guide the satellite into the payload bay. They were stuck. But Allen and Gardner weren't the kind of guys to give up when faced with obstacles. Improvisation became the name of the game. Joe Allen, although only 5 feet 6 inches and slender, was a former high school wrestling champion. So he leaned into what he knew. He was going to wrestle the 12,200-pound satellite into position with nothing but his hands and determination. Allen removed the MMU and instead strapped himself into a foot harness fixed to the shuttle. With his boots locked down, he stood upright like a cosmic atlas, holding the enormous satellite over his head. Fisher kept the Stinger steady using the Canadarm while Allen wrestled Palapa into the correct orientation. It's one of the most jaw-dropping moments ever captured on camera. A human being in space controlling a satellite by sheer force of will. The satellite was technically weightless, but its mass still required precise, careful handling. One wrong move and it could slam into the shuttle, causing catastrophic damage. After a grueling 6-hour spacewalk filled with stress, sweat, and sheer brilliance, Allen and Gardner finally managed to secure Palapa into the payload bay. But the mission wasn't over yet. The very next day they were back at it, this time targeting the Wester satellite. For this operation, Gardner piloted the MMU while Allen assisted. Fortunately, the clamp fit this time. With everything clicking into place, the Canadarm was able to do most of the lifting. The satellite recovery took half the time of the first mission with no need for satellite wrestling. Both satellites were now safely locked in for the ride home. With their precious payload secured, the Discovery crew headed back to Earth, having achieved something never before done in human spaceflight. The shuttle had proven that it could not only launch heavy satellites into orbit but bring them back intact. While the whole point of the mission may have been to save some rich insurers millions of dollars, what it truly represented was a monumental leap in human capability. The astronauts had pulled off a space rescue with limited tools, lots of training, and even more grit. This mission became a defining milestone in NASA's history and in the evolution of human space travel. But this high point was followed swiftly by tragedy. Just a year later, in January 1986, the Space Shuttle Challenger exploded shortly after launch, claiming the lives of all 7 crew members on board. The accident was a devastating blow not only to NASA but to the world's belief in the future of human spaceflight. In the aftermath, the U.S. government drastically changed its space policy. The shuttle program was scaled back. NASA would no longer use the orbiters for commercial satellite launches, and high-risk, daring operations like the Palapa recovery were quietly shelved. The MMU jetpacks would never fly again.